Hello everyone, welcome. This is Jay. Today I will give you a glimpse on Indian code IS 4651. This code deals with planning and design of ports and harbor structures. Essentially, this code is divided into 5 parts. Part 1 walks you through site investigation aspects. Part 2 is dedicated to earth pressure calculation. Since port structures are complex in nature, earth pressure analysis is quite comprehensive. Hence, the committee has formulated a separate manual. Moving on to part 3, we have loadings. This section covers different vertical live loads and horizontal loads like cargo loads, crane loads, seismic, wind and berthing forces. Also, this code tabulates different vessel characteristics that are likely seen on Indian coast. The next part of the code is general design consideration. Here the code discusses design philosophy to be followed, along with load combination and load factors. Also, there is a small section on fenders. Finally, the last section, part 5, deals with layout and functional requirements. Here the emphasis is given on geometric dimensions to be adapted for different structures within the port. Furthermore, there is a large section on harbor basin layout. So for the first part of the code, that is under site investigation, we have to collect several data starting from topological survey, under which survey maps of scale 1:50,000 and contour intervals of 20 meters are required. Moving on to meteorological data, information on 6 parameters are to be obtained. For wind data shall be collected for a period of at least 1 year. Anemometers should be installed at site to record velocity and direction of wind. Design cyclone should be computed from various parameters like maximum wind velocity, duration and pressure drop. As far as rainfall is concerned, data shall be collected for a minimum period of 3 years. This should cover maximum intensity and duration. Moving on to relative humidity, details on maximum, mean and minimum relative humidity for each month is to be collected for a minimum period of 5 years. For temperature, daily and seasonal variation may be noted. And for the last part, that is on barometric pressure, monthly average values would suffice. So oceanographic data constitutes a major chunk of information to be extracted. First, we have to collect tidal data, which is obtained from the tide tables published by the Survey of India. Data over a full metonic cycle of 19 years is required. Next, on wave aspects, storm data and synoptic charts can be obtained from Indian Meteorological Department. However, for critical projects, wave recorders may be installed. Storm surges can be inferred from tidal gauges and can also be computed from synoptic charts. Now, speaking on the currents, 3 parameters should be recorded. That is direction, strength and duration. This should be done at peak spring and neap tides for a whole year. Also, current readings should be taken at 3 points at depths of 0.1, 0.5 and 0.9 times the depth of water. For suspended load, salinity and temperature, values shall be recorded both during the dry and wet seasons and over the full tidal cycle during neap and spring tides. Similar to water currents, readings shall be obtained for 3 distinct points. Slope of the seabed is of paramount importance, which may be ascertained from hydrographic survey chart. Under geological data, type of bedrock along with faults, fissures and folds needs to be compiled. Also, information on crushing strength of rock will be an added advantage. Coming to soil investigation, 2 aspects needs to be probed. That is subsurface exploration and mean groundwater level. Special attention is required when soft strata is encountered at site. Typically, subsoil investigation is carried out as per IS 1892. Now, moving on to seismic data, Code of Reference IS 1893, Part 1 to Part 4 is to be adopted. Finally, we are headed to last section of data collection, that is on local resources. Material available near the vicinity of the site should be studied, along with skilled labor and machinery to carry out the construction activity with ease. Now we are moving on to the design philosophy. The code allows both working stress and limit state method of analysis, with more emphasis on working stress method. However, if you are designing a structure other than that of RCC or PSC material, only working stress method is to be followed. And it is not uncommon to use timber as a material for piles in harbor structures. Such a scenario mandates use of working stress method. This slide talks about a myriad forces that act on waterfront structures. Broadly, loads are classified into two groups, operational and environmental. Under operational loads, we have cargo loads, loads due to crane movement, braking and traction due to movement of goods train. Under environmental loads, we have forces due to wind, seismic and waves. Also, the berthing and mooring forces due to vessels is a separate category. So I'll make a comprehensive video on loadings in the near future. So we'll get a bit better picture of the same. In continuation with the loads, part 3 of the code dictates 4 load combinations to be followed as presented here. Typically, force due to wave is of high magnitude and will govern the design in most cases. This slide talks about part 5 of the code, that is on layout and functional requirements. Each heading listed here requires detailed discussion. Hence, I'll be covering in a separate video. I hope you like this introduction video and I'll catch you soon. Thank you.